Hello everybody, getting ready to do lesson 11.8 of Pre-Algebra Math, Part 1. And today's lesson has a 42-point classwork sheet and then a 20-point notebook sheet today. Mutually exclusive and overlapping events, probabilities of disjoint and overlapping events, Part 1. Teachers, today's bell work is multiple choice for number 1. And then make a box and whisker plot of the data down here, students. So it's quite extensive. Give your students 9-10 minutes. Welcome back for today's solutions. Here is solution for number 1. You set up a combination formula here and you get 70 for number 1. And then our box and whisker down here, you find your median. And then this is lower quartile is 30. And then upper quartile will be 40. And then here's our box and whisker here. Once you put that beneath a number line, you need to make a number line, students. If you need extra room, you should include an extra sheet. Send that in if you're a homeschooler or online schooler. Make sure you send in an extra sheet if you need the room, and you probably will. This is a extensive bell work here. Okay, into our lesson today, classwork 1. In this lesson, you'll find a probability that an event A or an event B occurs. To find a probability, first determine whether the events are disjoint or overlapping. Disjoint events or mutually exclusive events are events that have no outcomes in common. Excuse me. Overlapping events are events that have one or more outcomes in common. So there's a real difference. Okay, students, here is your vocabulary here in your own words. Define overlapping events and complementary events in your notebook, page 2 for 11.8 lesson, and then disjoint events and mutually exclusive events. Define those in your own words. Okay, for example, suppose you roll a number cube. The Venn diagram shows below, it illustrates example of disjoints and overlapping. So this would be a disjoint here, disjoint events. Event A would be a roll of 2. Event B would be to roll an odd number. So these would be disjoint here. Rolling a 2 and 1, 3, and a 5, that would be an odd number there. And then overlapping events would be like this. Roll an even and then roll a prime. So this would be rolling even here, would be a 2, and then event A will be rolling even, would be 2, 4, and 6. And then rolling a prime number would be a 2, 3, and a 5. These are prime here, 2, 3, and a 5. So the overlapping of these two would be the fact of rolling a 2 here. It's both an even number and a prime number. So that way, that defines an event. And then into our example here. Example 1, identify disjoint and overlapping events. Tell whether the events are disjoint or overlapping. So rolling a number cube. Event A, roll a number less than 4. Event B, roll a 5. So how would that turn out here? The outcomes for event A are 1, 2, and 3. The outcomes for event B would be is a 5, so rolling a 5. There are no outcomes in common here. So 1, 2, and 3, and 5 are disjoint events. So these events are disjoint here. Rolling a 5, and then rolling a number less than 4. And then for here, event 1, or rather example 1, tell whether the events are disjoint or overlapping. So randomly select a student. Event A, select a 7th grader student. Event B, select a boy. So in this situation, because some 7th graders are boys, the events have outcomes in common. the events are overlapping. So by selecting a 7th grader and a boy that is a 7th grader, that could be an overlapping, or would be an overlapping proposition there. Suppose you choose a book to read. Are the events choosing a hardcover book or choosing a fiction book disjoint or overlapping? Students, this is yours down here. You roll a number cube, tell whether the events are disjoint or overlapping, then find probability A or B. So event A, roll an odd, event B, roll a 1. So that's yours. Okay, so our guided practice becomes some hardcovers are fiction. The events have outcomes in common. The events are overlapping. And then down here, students, remember this is yours. Respond to that. Okay, probability of disjoints. The Venn diagram shows 2 disjoint events that involve rolling a number cube, 1, 2, and 3, and then 5 and 6 here. Event A, roll a number less than 4. That would describe event A. And then event B, roll a number greater than 4. That would be 5 and 6. And they are disjoint events. So that'd be a good definition for that. There are 6 possible outcomes. There are 5 favorable outcomes for event A or B. So probability A or B would equal 5 over 6. You can also find probability A or B by finding the sum of the probability of event A and the probability of event B. So they would be this here. You add the 2 probabilities together and you get 5 over 6 for that situation. The result should be the following rule. Probability of disjoint events. For 2 disjoint events, probability that either of the events occur is the sum of the probabilities of the event. So if A and B are disjoint, then probability A or B would be to add the probability of those 2 events together. So finding probability of disjoint events, 50 tickets are sold for a raffle. You buy 2 tickets and your friend buys 3 tickets. 1 ticket is randomly chosen as the winning ticket. What is probability that you or your friend wins the raffle? So the events are just disjoint because you and your friend cannot both win. Event A, you win the raffle. Event B, your friend wins the raffle. So these are your 2 possible events here. So the probability that you or your friend will win, A or B, is that you add the probabilities there together. So it'll be 5 over 50 or 1 out of 10 shot there. So the probability that you and your friend win would be 1 out of 10. Okay, into our next guided practice here. Election candidate received 35%, B received 22%, C received 43% of the vote. If you randomly select a person from all who voted, what is the probability that the person voted for either A or candidate B? Students, this is yours down here. They're disjoint. Find probability A or B. So we're going to continue up here with our guided practice. Okay, this situation here, event, candidate event. Candidate A is picked, candidate B is picked. So we add those together and we get 57 over 100. The probability that the person voted for either A or B is 57%. Students, this is yours down here. And that is lesson 11.8, part 1, part 2, part 3, available here at the email. Thank you very much.